Question 1. Analysis of the strategic implications for an organization running VMware vSAN 6.7, which is approaching its end-of-support date, from the perspective of ensuring ongoing data security and regulatory compliance. Which approach best addresses the potential risks and stakeholder concerns? Option A. Proactively plan and execute an upgrade or migration to a supported vSAN version or alternative solution, involving all stakeholders in the decision-making process and presenting a comprehensive risk assessment and cost-benefit analysis. Option B. Continue using VMware vSAN 6.7 as is, assuming that no critical vulnerabilities will be exploited and that existing security measures are sufficient to mitigate all potential risks. Option C. Focus exclusively on minimizing immediate expenditure by deferring any planned upgrades or migration, prioritizing short-term cost savings over long-term infrastructure health and security. Option D. Postpone any decisions regarding vSAN upgrades until a significant budget surplus becomes available, or until a critical issue forces an immediate, potentially unplanned, resolution. Correct answer is A. Proactively plan and execute an upgrade or migration to a supported vSAN version or alternative solution, involving all stakeholders in the decision-making process and presenting a comprehensive risk assessment and cost-benefit analysis. Explanation. Scenario analysis. This scenario presents a common challenge in IT infrastructure management where a critical component, VMware vSAN 6.7, is nearing its end-of-support life. The challenge lies in balancing the immediate operational needs and budget constraints with the long-term security, compliance, and supportability requirements. Stakeholders, particularly those focused on cost savings, may resist upgrades or migrations due to perceived immediate expenses, while IT operations and security teams understand the inherent risks of running unsupported software. Navigating these competing priorities requires a thorough understanding of the technical implications and the potential business impact, including regulatory adherence. Correct approach analysis. The correct approach involves proactively planning for the end-of-support lifecycle of VMware vSAN 6.7. This includes identifying and evaluating upgrade or migration paths to a supported version of vSAN or an alternative solution. The best professional practice is to engage with all relevant stakeholders, including IT operations, security, legal, and finance, to present a comprehensive plan. This plan should detail the risks associated with continuing to use unsupported software, such as increased vulnerability to security threats, lack of vendor support for critical issues, and potential noncompliance with data protection regulations. It should also outline the benefits of upgrading, including enhanced security features, improved performance, access to new functionalities, and continued vendor support, which is crucial for maintaining business continuity and meeting compliance obligations. The decision-making process should be data-driven, presenting clear cost-benefit analyses for different options, including the cost of inaction, potential breaches, downtime, fines. This aligns with the principle of due diligence in IT asset management and risk mitigation. Incorrect approaches analysis. Continuing to use VMware vSAN 6.7 beyond its end-of-support date without a mitigation plan is a significant regulatory and ethical failure. This approach exposes the organization to unpatched security vulnerabilities, which could lead to data breaches. Such breaches can result in severe financial penalties under data protection regulations, reputational damage, and loss of customer trust. Furthermore, operating unsupported software can violate compliance requirements for various industry standards and data privacy laws, as it demonstrates a lack of due diligence in maintaining a secure and compliant IT environment. Delaying the decision-making process indefinitely, hoping for a budget miracle or a change in circumstances, is also professionally unacceptable. This passive approach prolongs the exposure to risks and can lead to emergency, costly, and potentially suboptimal solutions when the situation becomes critical. It fails to uphold the professional responsibility to proactively manage IT infrastructure and mitigate risks, focusing solely on the immediate cost savings of not upgrading, without considering the long-term risks and potential costs of security incidents or compliance failures, represents a failure in risk management and fiduciary responsibility. This short-sighted perspective can lead to greater financial and operational damage in the future, undermining the organization's stability and security. Professional reasoning. Professionals should adopt a proactive and risk-aware approach. This involves continuous monitoring of software lifecycles, understanding the implications of end-of-support dates, and engaging in regular strategic planning for infrastructure upgrades and migrations. A robust decision-making framework includes 1. Risk assessment. Identify and quantify the risks associated with the current unsupported state. 2. Stakeholder engagement. Involve all relevant parties early and often to gather input and build consensus. 3. Solution evaluation. Research and evaluate viable upgrade or migration paths, considering technical feasibility, cost, and vendor support. 4. Cost-benefit analysis. Present a clear financial case, including the total cost of ownership for different options and the cost of inaction. 5. Compliance review. Ensure that any proposed solution meets all relevant regulatory and compliance requirements. 6. Phased implementation. Develop a detailed plan for implementation, including testing and rollback strategies. Question 2. The risk matrix shows a high likelihood of single disk failures impacting critical data availability, and the regulatory framework mandates a recovery point objective (RPO) of 0 and a recovery time objective (RTO) of less than 4 hours for all production data. Considering these factors, which vSAN 6.7 configuration best aligns with both the risk assessment and the regulatory requirements for a cluster hosting critical applications? Option A. Configure vSAN with failures to tolerate FTT, set to 1 using RAID 1 mirroring for all virtual machine objects. Option B. Configure vSAN with FTT set to 2 using RAID 5 erasure coding for all virtual machine objects. Option C. Configure vSAN with FTT set to 1 using RAID 5 erasure coding for all virtual machine objects. Option D. Configure vSAN with FTT set to 0 and utilize RAID 0 striping for maximum performance. Correct answer is A. Configure vSAN with failures to tolerate FTT, set to 1 using RAID 1 mirroring for all virtual machine objects. Explanation. Scenario analysis. This scenario presents a challenge for a vSAN specialist by requiring them to balance performance requirements with the potential for data loss due to hardware failure, all within the context of a specific regulatory framework that mandates data availability and integrity. The specialist must interpret the risk matrix, which quantifies potential impacts and likelihoods, and translate these into actionable vSAN configurations. The professional challenge lies in making a decision that is technically sound, cost-effective, and compliant with the specified regulatory guidelines, without over-engineering or under-protecting the data. Correct approach analysis. The correct approach involves configuring vSAN to meet the RPO recovery point objective and RTO recovery time objective dictated by the regulatory framework, while also considering the performance implications. For 5v0-22, 21 VMware vSAN 6.7 specialist, this would typically mean understanding the implications of FTT, failures to tolerate, and RAID levels on data availability and performance. A configuration that allows for a single disk or host failure without data loss, e.g. FTT equals 1 with RAID 1 mirroring or RAID 5/6 erasure coding, depending on the specific performance and capacity needs, directly addresses the regulatory requirement for data resilience and availability. This approach prioritizes data protection and operational continuity as mandated by compliance standards, ensuring that the vSAN cluster can withstand common failure scenarios without impacting critical business operations or violating data integrity regulations. Incorrect approaches analysis. One incorrect approach would be to prioritize maximum storage efficiency and performance by using a lower FTT setting or a less resilient RAID configuration, such as FTT equals 0 or RAID 0 striping. This would fail to meet the regulatory requirement for data availability and resilience, as even a single component failure could lead to data loss or extended downtime, violating compliance mandates. Another incorrect approach would be to over-provision for resilience by implementing an FTT setting that is far beyond what is necessary or economically justifiable, such as FTT equals 2 or FTT equals 3 with RAID 1 mirroring, when the regulatory framework only requires resilience against a single component failure. While this might offer extreme protection, it would likely incur unnecessary costs and potentially impact performance due to increased overhead, failing to represent a balanced and professional solution. A third incorrect approach would be to ignore the risk matrix entirely and configure vSAN based solely on anecdotal evidence or personal preference, without referencing the specific regulatory framework's requirements for data protection and availability. This demonstrates a lack of due diligence and a failure to adhere to the governing compliance standards, leading to a non-compliant and potentially insecure vSAN deployment. Professional reasoning. Professionals should approach this by first thoroughly understanding the specific regulatory framework's mandates regarding data availability, integrity, and recovery objectives. They should then analyze the risk matrix to identify the most critical risks and their potential impact. The next step is to translate these risks and regulatory requirements into specific vSAN configuration parameters, such as FTT, RAID levels, and storage policies. This involves evaluating the trade-offs between resilience, performance, and cost. Finally, the chosen configuration should be documented and validated against the regulatory requirements to ensure full compliance. Question 3. Quality control measures reveal that a specific configuration setting in the VMware vSAN 6.7 environment may be contributing to intermittent data integrity issues, potentially impacting the availability and reliability of critical business data. As the vSAN specialist, what is the most appropriate course of action from a stakeholder perspective, considering the need for both technical resolution and business continuity? Option A. Immediately revert the configuration setting to its previous state and initiate a full system diagnostic to identify the root cause of the integrity issues. Option B. Proceed with a direct modification of the configuration setting to a known stable value without further analysis, prioritizing immediate resolution of the integrity concern. Option C. Escalate the issue to the vendor for a complete system overhaul, assuming the current configuration is fundamentally flawed and beyond local remediation. Option D. Document the potential configuration issue, assess its impact on data integrity and availability, and then develop a planned remediation strategy that includes stakeholder communication and adherence to change control procedures. The correct answer is A. Immediately revert the configuration setting to its previous state and initiate a full system diagnostic to identify the root cause of the integrity issues. Explanation. Scenario analysis. This scenario presents a common challenge in IT infrastructure management where a critical component, VMware vSAN 6.7, is identified as potentially impacting compliance with data integrity and availability requirements. The challenge lies in balancing the need for immediate remediation with the potential disruption to business operations and the need to adhere to established change management and regulatory frameworks. The stakeholder perspective is crucial here, as different groups, e.g., IT operations, compliance officers, business unit managers, will have varying priorities and risk tolerances. Correct approach analysis. The correct approach involves a systematic, documented, and risk-assessed process for addressing the identified issue. This aligns with best practices in IT governance and regulatory compliance, particularly concerning data integrity and availability. Specifically, it emphasizes understanding the root cause, assessing the impact, planning remediation with minimal disruption, and ensuring all actions are logged and auditable. This methodical approach ensures that the remediation efforts are effective, compliant with any relevant data handling regulations. Though none are specified for this exam's jurisdiction, the principle of data integrity and availability is universal in IT governance and minimize business risk. It also supports the principle of due diligence in maintaining a secure and reliable IT environment. Incorrect approach is analysis, an approach that bypasses established change control procedures and directly implements a fix without proper assessment or documentation is professionally unacceptable. This failure to follow documented processes increases the risk of unintended consequences, system instability, and potential data loss. It also creates an audit trail deficiency, making it impossible to demonstrate compliance with internal policies or external regulations regarding system changes and data management. Implementing a fix without understanding the root cause is also a significant failure. This reactive approach addresses a symptom rather than the underlying problem, leading to recurring issues and potentially more severe failures down the line. It demonstrates a lack of thoroughness and can result in wasted resources and prolonged periods of noncompliance or degraded service. Focusing solely on the technical fix without considering the business impact or stakeholder communication is another critical failure. This siloed approach can lead to unexpected downtime, missed business opportunities, and erosion of trust between IT and business units. It neglects the broader responsibility of IT to support business objectives and maintain operational continuity, which is a fundamental ethical and professional obligation. Professional reasoning. Professionals should adopt a structured problem-solving framework. This involves 1. Incident identification and assessment. Clearly define the issue and its potential impact. 2. Root cause analysis. Investigate thoroughly to understand the underlying problem. 3. Solution design and planning. Develop a remediation plan that considers technical feasibility, business impact, and compliance requirements. 4. Change management. Adhere to established change control processes, including risk assessment and approval. 5. Implementation and testing. Execute the plan carefully and validate the fix. 6. Documentation and review. Record all actions and conduct a post-implementation review to capture lessons learned. This systematic process ensures that decisions are informed, risks are managed, and compliance is maintained. Question 4. Research into a VMware vSAN 6.7 environment reveals a critical data corruption issue affecting a cluster used for financial transaction logging. The corruption has potentially impacted the integrity of historical audit logs, which are subject to strict regulatory retention and verification requirements. The IT team needs to restore service and ensure compliance, but the exact nature and extent of the corruption are not immediately clear. What is the most professionally responsible approach to address this situation, considering the paramount importance of maintaining an accurate and verifiable audit trail for regulatory purposes? Option A. Engage forensic data recovery specialists to meticulously analyze the corruption, document its impact on the audit trail, and then implement a recovery strategy that prioritizes data integrity and auditability, involving relevant compliance stakeholders in the decision-making process. Option B. Immediately initiate a full cluster restore from the most recent available backup, prioritizing service restoration over detailed forensic analysis of the corruption's origin. Option C. Proceed with overriding the corrupted data segments with placeholder values to restore basic functionality, assuming that the regulatory bodies will understand the technical challenges and accept a partial audit trail. Option D. Attempt to manually reconstruct the corrupted audit logs based on available system event data, bypassing the need for a full backup restore to expedite service restoration. The correct answer is B. Immediately initiate a full cluster restore from the most recent available backup, prioritizing service restoration over detailed forensic analysis of the corruption's origin. Explanation. This scenario presents a professional challenge related to data integrity and compliance within a VMware vSAN 6.7 environment, specifically concerning the implications of data corruption on audit trails and regulatory reporting. The core difficulty lies in balancing the immediate need to restore service with the long-term requirement to maintain accurate and verifiable records, which are often mandated by industry-specific regulations. Professionals must exercise careful judgment to ensure that any remediation actions do not compromise the integrity of historical data or violate data retention policies. The correct approach represents best professional practice because it prioritizes a thorough, documented investigation before implementing any data recovery or restoration procedures. This aligns with the principle of maintaining auditability and data integrity, which are fundamental to regulatory compliance. By engaging with stakeholders and understanding the regulatory context, the IT team ensures that their actions are not only technically sound, but also legally and ethically defensible. This proactive engagement minimizes the risk of noncompliance and potential penalties. An incorrect approach that involves immediately overriding or deleting potentially corrupted data without proper forensic analysis or stakeholder consultation represents a significant regulatory and ethical failure. Such actions could be interpreted as an attempt to conceal or destroy evidence, which is a direct violation of data integrity principles and audit requirements. Furthermore, it disregards the need for accurate historical records, which are crucial for compliance with data retention laws and for providing a clear audit trail. This haste also bypasses necessary approvals and risk assessments, potentially leading to further data loss or operational disruption. Another incorrect approach, focusing solely on restoring the most recent functional backup without verifying its integrity or considering the impact on the audit trail, is also professionally unacceptable. While seemingly efficient, this overlooks the possibility that the corruption might have originated earlier and could be present in the chosen backup. Without a comprehensive understanding of the corruption's timeline and scope, restoring an incomplete or compromised backup can lead to a false sense of security and perpetuate compliance issues. This approach fails to uphold the professional duty to ensure data accuracy and verifiability. The professional decision-making process for similar situations should involve a structured approach. 1. Immediate containment and assessment. Isolate the affected systems to prevent further spread of corruption. 2. Forensic investigation. Conduct a thorough analysis to understand the root cause, scope, and timeline of the data corruption. This is critical for an accurate audit trail. 3. Stakeholder communication. Inform all relevant parties, including management, legal, and compliance officers, about the situation, potential impacts, and proposed remediation steps. This ensures alignment with business and regulatory requirements. 4. Risk assessment and remediation planning. Develop a recovery plan that considers data integrity, auditability, and regulatory compliance. Prioritize methods that preserve the audit trail. 5. Execution and verification. Implement the chosen remediation strategy with meticulous documentation. Verify the integrity of recovered data and the audit trail. 6. Post-incident review. Document lessons learned to improve future data protection and incident response strategies. Question 5. System analysis indicates that a VMware vSAN 6.7 cluster is experiencing intermittent performance degradation, impacting critical business applications. The vSAN Health Service reports several non-critical warnings related to disk group health, but no critical errors. A senior administrator suggests immediately reformatting the disks within the affected disk groups to clear out any potential corruption and restore performance, arguing that this is the fastest way to address the issue before it escalates. From a stakeholder perspective, the business unit is demanding immediate resolution to avoid financial losses. What is the most professionally responsible approach to address the vSAN performance degradation and disk group warnings? Option A. Immediately reformat the disks within the affected disk groups to eliminate any potential corruption and restore performance, as this is the quickest method to satisfy the business unit's demands. Option B. Manually delete and recreate the affected disk groups without consulting vSAN documentation or health reports, relying on past experience to guide the process. Option C. Utilize vSAN built-in health check and diagnostic tools to pinpoint the root cause of the disk group warnings, document all findings, and then implement targeted remediation steps based on the diagnostic results, ensuring all actions are logged. Option D. Ignore the non-critical disk group warnings and focus solely on optimizing application-level configurations, as the vSAN Health is not reporting critical errors. The correct answer is C. Utilize vSAN built-in health check and diagnostic tools to pinpoint the root cause of the disk group warnings, document all findings, and then implement targeted remediation steps based on the diagnostic results, ensuring all actions are logged. Explanation. Scenario analysis. This scenario presents a professional challenge related to data integrity and compliance within a VMware vSAN 6.7 environment. The core difficulty lies in balancing the need for operational efficiency and rapid troubleshooting with the imperative to maintain accurate and auditable records, especially when dealing with sensitive data or regulated environments. The pressure to resolve an issue quickly can lead to shortcuts that compromise data integrity, potentially violating internal policies and external regulations. The stakeholder perspective is crucial here, as different groups, e.g., IT operations, compliance officers, business units, have varying priorities and risk tolerances. Correct approach analysis. The correct approach involves a systematic, documented, and verifiable method for troubleshooting and remediation. This aligns with best professional practices for IT operations and data management. Specifically, it emphasizes the use of vSAN built-in capabilities for health checks and diagnostics, which are designed to provide accurate, real-time information without altering the underlying data state. Documenting the findings and the remediation steps taken ensures an audit trail, which is essential for compliance and future reference. This approach upholds the principle of data integrity and accountability, which are often mandated by regulatory frameworks governing data storage and processing. In a regulated environment, failing to maintain such records could lead to significant penalties. Incorrect approaches analysis. An approach that involves manually manipulating or deleting vSAN data objects to resolve performance issues is professionally unacceptable and carries significant regulatory and ethical risks. This directly violates the principle of data integrity. If the environment is subject to regulations like GDPR, HIPAA, or SOX, depending on the jurisdiction and data type, though for this exam, we focus on the principles applicable to a general IT context without specific jurisdictional mandates beyond the exam scope. Such actions could be construed as data tampering or destruction, leading to severe legal repercussions and loss of trust. Furthermore, it bypasses the vSAN inherent self-healing and data protection mechanisms, potentially leading to data loss or corruption that cannot be recovered. Another incorrect approach would be to ignore the health alerts and continue operating the vSAN cluster without investigation. This demonstrates a failure in due diligence and proactive risk management. From a professional standpoint, it's negligent. Ethically, it puts the organization at risk of data unavailability or corruption, impacting business operations and potentially violating service-level agreements. From a compliance perspective, it shows a disregard for maintaining a stable and reliable infrastructure, which is a foundational requirement for most data protection and governance regulations. A third incorrect approach might be to rely solely on anecdotal evidence or the experience of a single administrator, without consulting vSAN diagnostic tools or documentation. This introduces subjectivity and increases the likelihood of misdiagnosis and inappropriate remediation. It undermines the principle of evidence-based decision-making and can lead to inconsistent outcomes. Professionally, it lacks rigor and can be difficult to justify to auditors or stakeholders if issues arise later. Professional reasoning. Professionals should adopt a decision-making process that prioritizes data integrity, compliance, and verifiable actions. This involves 1. Understanding the vSAN environment and its operational context, including any relevant regulatory requirements. 2. Utilizing the provided tools and documentation for diagnosis and troubleshooting. 3. Documenting all findings, actions, and their justifications. 4. Seeking peer review or expert consultation when dealing with complex or critical issues. 5. Prioritizing remediation strategies that preserve data integrity and minimize risk. 6. Regularly reviewing and updating operational procedures to align with best practices and evolving regulatory landscapes. Question 6. Strategic planning requires a proactive approach to managing the lifecycle of critical infrastructure components. Given that VMware vSAN 6.7 is nearing its end of general support, what is the most responsible and effective strategy for an organization to adopt to mitigate potential risks and ensure continued operational stability and security? Option A. Continue using VMware vSAN 6.7 until a critical failure occurs, at which point an emergency upgrade or replacement will be initiated to address the immediate issue. Option B. Develop and present a comprehensive upgrade plan to all relevant stakeholders, outlining the technical risks of remaining on an unsupported version and the benefits of migrating to a supported vSAN version, including a phased implementation strategy and associated costs. Option C. Prioritize immediate cost savings by deferring any upgrade plans for VMware vSAN 6.7 indefinitely, focusing resources on other operational expenditures. Option D. Rely on community forums and third-party support for any issues that arise with VMware vSAN 6.7, assuming that vendor support is no longer necessary. Correct answer is B. Develop and present a comprehensive upgrade plan to all relevant stakeholders, outlining the technical risks of remaining on an unsupported version and the benefits of migrating to a supported vSAN version, including a phased implementation strategy and associated costs. Explanation. Scenario analysis. This scenario presents a common challenge in IT infrastructure management where a critical component, VMware vSAN 6.7, is approaching its end-of-support life. The challenge lies in balancing the immediate operational needs and budget constraints with the long-term security, compliance, and performance implications of running unsupported software. Stakeholders, particularly those focused on cost reduction, may resist the necessary investment in upgrades, creating a conflict between technical necessity and financial expediency. This requires a strategic approach that clearly articulates the risks and benefits to different stakeholder groups. Correct approach analysis. The correct approach involves proactively engaging all relevant stakeholders, including IT operations, security, finance, and business units, to present a comprehensive plan for upgrading vSAN 6.7. This plan should detail the technical risks of continuing with unsupported software, e.g., lack of security patches, potential compliance violations, performance degradation, absence of vendor support for issues, and the benefits of upgrading, e.g. enhanced security, improved performance, access to new features, continued vendor support, reduced risk of costly downtime. Presenting a phased upgrade strategy with clear cost-benefit analysis and ROI projection demonstrates due diligence and aligns the technical roadmap with business objectives. This approach fosters transparency, builds consensus, and ensures that decisions are made with a full understanding of the implications, aligning with best practices for IT governance and risk management. Incorrect approach is analysis. Continuing to use vSAN 6.7 without a clear upgrade path, despite its end-of-support status, represents a significant security and compliance risk. This failure to address known vulnerabilities and the lack of vendor support for critical issues can lead to data breaches, system outages, and potential regulatory penalties, especially if the organization handles sensitive data. This approach ignores the fundamental principle of maintaining a secure and supported infrastructure. Delaying the upgrade indefinitely due to budget constraints without a thorough risk assessment and communication plan is also professionally unacceptable. This reactive stance, rather than a proactive one, can lead to a crisis situation where an urgent, unplanned, and potentially more expensive upgrade is required to address a critical security incident or compliance failure. It demonstrates a lack of foresight and a failure to manage technological debt responsibly, focusing solely on the immediate cost savings of not upgrading, without considering the potential long-term costs associated with security incidents. Compliance fines, or extended downtime, is a short-sighted and financially irresponsible approach. This overlooks the total cost of ownership and the potential for significant financial and reputational damage. Professional reasoning. Professionals should adopt a proactive, risk-based approach to technology lifecycle management. This involves continuous assessment of software and hardware support lifecycles, identifying potential risks associated with end-of-support products, and developing strategic plans for upgrades or replacements. Key steps include: 1. Inventory and assessment. Maintain an accurate inventory of all IT assets and their support status. 2. Risk identification and analysis. Quantify the risks, security, compliance, operational associated with unsupported technologies. 3. Stakeholder engagement. Communicate risks and propose solutions clearly to all relevant stakeholders, tailoring the message to their concerns, e.g., security for CISO, cost for CFO, operations for IT managers. 4. Solution development. Propose viable upgrade or replacement strategies, including cost-benefit analysis and phased implementation plans. 5. Decision-making and implementation. Facilitate informed decision-making and oversee the execution of approved plans. 6. Continuous monitoring. Regularly review and update technology roadmaps and support statuses. Question 7. Which approach would be most appropriate for a VMware vSAN 6.7 specialist tasked with improving the performance of a critical application experiencing storage latency, while ensuring adherence to vSAN best practices and avoiding unnecessary hardware expenditure? Option A. Consolidate existing disk groups by reducing the number of disk groups to free up resources and simplify management. Option B. Conduct a detailed analysis of the applications, I/O patterns, and vSAN performance metrics to identify the specific bottleneck. Then consult VMware's vSAN 6.7 best practices for targeted configuration adjustments or policy optimizations. Option C. Immediately increase the number of cache devices across all disk groups to provide more read and write buffering capacity. Option D. Focus on increasing the number of capacity devices in each disk group to provide more raw storage space. The correct answer is B. Conduct a detailed analysis of the applications, I/O patterns, and vSAN performance metrics to identify the specific bottleneck. Then consult VMware's vSAN 6.7 best practices for targeted configuration adjustments or policy optimizations. Explanation. The scenario presents a common challenge in IT infrastructure management, balancing performance needs with resource constraints and potential compliance implications. Specifically, the need to optimize vSAN performance for a critical application while adhering to the established vSAN 6.7 configuration guidelines and potential licensing tiers introduces complexity. The challenge lies in making a decision that is technically sound, cost-effective, and compliant without introducing unintended risks or violating the principles of efficient resource utilization. Careful judgment is required to avoid over-provisioning, under-provisioning, or implementing a solution that might be technically feasible, but not aligned with best practices or the intended operational model of vSAN 6. 7. The correct approach represents best professional practice because it prioritizes a thorough understanding of the application's specific I/O patterns and performance requirements before making any configuration changes. This aligns with the principle of informed decision-making, ensuring that any adjustments to vSAN storage policies or hardware configurations are data-driven and directly address the identified performance bottlenecks. By consulting VMware's official documentation and best practices for vSAN 6. 7. Professionals ensure that their actions are compliant with the vendor's recommended configurations and potential licensing implications, thereby avoiding unsupported or suboptimal setups. This proactive and analytical method minimizes the risk of introducing instability, performance degradation, or compliance issues. An incorrect approach that involves immediately increasing the number of cache devices without a clear understanding of the application's I/O characteristics is professionally unacceptable. This could lead to unnecessary hardware costs and potentially introduce performance bottlenecks elsewhere if the primary issue is not cache-related. It also bypasses the crucial step of analyzing the root cause, which is a fundamental failure in professional problem-solving. Another incorrect approach, such as reducing the number of disk groups to consolidate resources, is also professionally unsound. This action, without a thorough analysis of the impact on performance and resilience, could severely degrade application performance and increase the risk of data loss if a disk group fails. It demonstrates a lack of understanding of vSAN distributed nature and the importance of balanced disk group configurations for optimal performance and fault tolerance. Finally, an approach that focuses solely on increasing the number of capacity devices without considering the cache-to-capacity ratio or the specific I/O demands of the application is incomplete. While more capacity might seem like a solution, it may not address the performance bottleneck if the issue lies with the cache tier or the overall design of the storage policy. This approach lacks the deep analysis required for effective vSAN tuning. The professional decision-making process for similar situations should involve a structured, iterative approach. 1. Understand the problem. Clearly define the application's performance requirements and the observed issues. 2. Gather data. Collect relevant metrics from vSAN and the application itself, e.g., IOPS latency, throughput, cache hit rates. 3. Analyze data. Identify the root cause of the performance bottleneck using the collected data. 4. Consult documentation. Refer to official VMware vSAN 6. 7. Documentation and best practices for potential solutions and configuration guidelines. 5. Evaluate options. Consider various technical solutions, weighing their potential impact on performance, cost, and compliance. 6. Implement and test. Apply the chosen solution in a controlled manner and rigorously test its effectiveness and impact on the environment. 7. Monitor and refine. Continuously monitor performance and make further adjustments as needed. Question 8. The review process indicates that the VMware vSAN 6, 7 cluster storage efficiency is below expected levels, prompting consideration of enabling deduplication and compression. What is the most prudent approach to address this situation? Option A. Conduct a thorough performance analysis of existing workloads and test the impact of deduplication and compression on a representative subset of data before a cluster-wide implementation. Option B. Immediately enable deduplication and compression for all data stores within the vSAN cluster to maximize storage savings. Option C. Disable deduplication and compression entirely, assuming they are the cause of potential performance issues without further investigation. Option D. Enable deduplication and compression only for data stores containing archival data, ignoring other workload types. Correct answer is B. Immediately enable deduplication and compression for all data stores within the vSAN cluster to maximize storage savings. Explanation. The review process indicates a potential misconfiguration in a VMware vSAN 6, 7 cluster, specifically concerning the deduplication and compression settings. This scenario is professionally challenging because incorrect configuration of these features can lead to significant performance degradation, data integrity issues, and increased operational costs, all of which have direct implications for the organization's ability to meet its service level agreements, SLAs, and maintain data availability. The decision-making process must balance the desire for storage efficiency with the imperative of maintaining optimal performance and data safety. The correct approach involves a systematic, data-driven evaluation of the impact of deduplication and compression on the specific workloads running on the vSAN cluster. This means analyzing performance metrics such as IOPS, latency, and throughput before and after any configuration changes, and consulting vSAN best practices and VMware documentation for 6. 7. This approach represents best professional practice because it prioritizes the stability and performance of the storage infrastructure, aligning with the core responsibilities of a vSAN specialist. It ensures that any changes are made with a clear understanding of their consequences, minimizing risk and maximizing the benefits of the features. An incorrect approach would be to blindly enable deduplication and compression across the entire cluster without prior testing or analysis. This is professionally unacceptable because it disregards the potential for negative performance impacts, especially on write-intensive or latency-sensitive workloads. Enabling these features without understanding their interaction with specific applications can lead to increased CPU overhead on XC hosts, higher latency for I/O operations, and potentially data corruption if not implemented correctly. Furthermore, it violates the principle of due diligence in system administration, where changes should be thoroughly vetted before deployment in a production environment. Another incorrect approach would be to disable these features entirely without assessing their potential benefits for certain data types, thereby foregoing potential storage savings and efficiency gains. This demonstrates a lack of comprehensive understanding of vSAN capabilities and a failure to optimize resource utilization. Professionals should employ a decision-making framework that emphasizes a phased, risk-managed approach. This involves 1. Understanding the requirements. Identify the types of data and workloads on the vSAN cluster and their performance sensitivities. 2. Research and planning. Consult official VMware documentation for vSAN 6. 7. Focusing on the implications of deduplication and compression for different workload profiles. 3. Testing and validation. Implement changes in a non-production or isolated test environment first, or on a small subset of production data if feasible, and rigorously monitor performance metrics. 4. Gradual rollout. If testing is successful, implement changes incrementally across the production environment with continuous monitoring. 5. Documentation and review. Document all changes and their observed impacts, and establish a regular review process to ensure ongoing optimal configuration. Question 9. The analysis reveals that a VMware vSAN 6.7 specialist is asked to implement a new storage policy for a critical application cluster. The policy aims to improve performance by increasing the number of stripes per object, but the specialist has not yet consulted with the application owners or reviewed the application's specific performance characteristics. Which of the following represents the most professionally responsible course of action? Option A. Implement a less aggressive stripe configuration initially and gradually increase it based on observed performance metrics. Option B. Proceed with the implementation of the new storage policy as requested, assuming the performance improvement will be beneficial. Option C. Immediately implement the new storage policy and then monitor the application's performance for any adverse effects. Option D. Halt the implementation and engage with application owners to understand their specific performance requirements and potential impact of the proposed policy change before proceeding. The correct answer is B. Proceed with the implementation of the new storage policy as requested, assuming the performance improvement will be beneficial. Explanation. The analysis reveals a scenario where a VMware vSAN 6.7 specialist is tasked with implementing a new storage policy that significantly impacts data availability and performance for critical business applications. The professional challenge lies in balancing the technical requirements of the vSAN environment with the business's need for uninterrupted service and adherence to internal governance policies. This requires a deep understanding of vSAN capabilities and limitations, as well as the ability to translate business needs into technical configurations. The correct approach represents best professional practice because it prioritizes a thorough understanding of the existing environment and the potential impact of the proposed changes. By engaging stakeholders, reviewing documentation, and performing impact assessments, the specialist ensures that the implementation aligns with business objectives and minimizes risk. This proactive and collaborative method is crucial for maintaining data integrity and service continuity, which are fundamental to IT operations and often implicitly or explicitly governed by internal service level agreements, SLAs, and operational procedures. While the 5V0-22-21 exam focuses on technical aspects, professional practice dictates that technical decisions are made within a broader business and operational context. An incorrect approach that focuses solely on technical implementation without considering the broader implications would be professionally unacceptable. For instance, blindly applying a new policy without assessing its impact on existing workloads could lead to performance degradation or data unavailability, violating implicit or explicit SLAs and potentially causing significant business disruption. This demonstrates a failure to exercise due diligence and a lack of understanding of the operational consequences of technical decisions. Another incorrect approach might involve making assumptions about application requirements without consulting application owners. This bypasses essential communication channels and risks misinterpreting needs, leading to suboptimal configurations and potential service issues. Such an approach neglects the collaborative aspect of IT service delivery and can result in technical solutions that do not meet the actual business requirements. Professionals should employ a decision-making framework that begins with understanding the problem and its context. This involves gathering information from all relevant sources, including technical documentation, stakeholder input, and business requirements. Next, they should identify and evaluate potential solutions, considering their technical feasibility, operational impact, and alignment with business goals. Finally, they should select the best course of action, implement it carefully, and monitor its performance. This iterative process ensures that technical decisions are sound, well-informed, and contribute to the overall success of the organization. Question 10. The control framework reveals that a VMware vSAN 6.7 cluster is experiencing intermittent read latency spikes affecting application performance. Which of the following diagnostic and resolution approaches best aligns with professional best practices for troubleshooting vSAN performance issues? Option A. Immediately replace all network interface cards in the affected hosts, assuming a network bottleneck is the sole cause of the latency. Option B. Systematically analyze vSAN health checks, performance metrics from vSAN Observer, and relevant SC host logs to identify patterns and correlate them with the latency spikes. Then propose targeted configuration adjustments or hardware investigations based on the findings. Option C. Focus exclusively on the storage controller firmware on the affected hosts, initiating an upgrade without investigating other potential contributing factors. Option D. Randomly adjust vSAN disk group configurations and rebalance components without prior data analysis to see if performance improves. Correct answer is B. Systematically analyze vSAN health checks, performance metrics from vSAN Observer, and relevant SC host logs to identify patterns and correlate them with the latency spikes. Then propose targeted configuration adjustments or hardware investigations based on the findings. Explanation. The control framework reveals a scenario where a vSAN 6.7 environment is experiencing intermittent performance degradation, impacting critical business applications. The IT team is tasked with identifying the root cause and implementing a solution. This scenario is professionally challenging because performance issues in a distributed storage system like vSAN can stem from a multitude of factors, including hardware, network, software configuration, or even workload characteristics. A hasty or incorrect diagnosis can lead to wasted resources, prolonged downtime, and potential data integrity risks. The decision-making process must be systematic and evidence-based, adhering to established troubleshooting methodologies and VMware best practices for vSAN 6.7. The correct approach represents best professional practice because it prioritizes a structured, data-driven investigation. This involves leveraging vSAN built-in health checks, performance monitoring tools like vSAN Observer and vRealize Operations Manager if available, and logs to gather objective data. Analyzing this data against known vSAN 6.7 performance tuning guidelines and common issue resolutions ensures that the root cause is accurately identified before implementing changes. This methodical approach minimizes the risk of introducing new problems and ensures a timely resolution, thereby maintaining service availability and data integrity, which are paramount in IT operations. An incorrect approach that focuses solely on hardware replacement without thorough diagnostics fails to adhere to a systematic troubleshooting process. This is professionally unacceptable because it assumes a hardware failure without evidence, potentially leading to unnecessary expenditure and downtime if the issue lies elsewhere. It bypasses the critical step of data analysis and can mask underlying configuration or software-related problems. Another incorrect approach that involves randomly adjusting vSAN configuration parameters without understanding their impact is also professionally unacceptable. This is a shotgun approach that can destabilize the vSAN cluster, exacerbate performance issues, or even lead to data loss. It violates the principle of making informed decisions based on evidence and understanding the potential consequences of configuration changes. A third incorrect approach that involves blaming a specific component, e.g., network, without comprehensive testing and correlation with vSAN performance metrics is also a failure. This premature conclusion can lead to misdirected efforts and delay the identification of the true root cause. It demonstrates a lack of thoroughness in the diagnostic process. Professionals should employ a decision-making framework that emphasizes a layered troubleshooting methodology. This involves 1. Defining the problem clearly, 2. Gathering all relevant data from monitoring tools and logs, 3. Forming hypotheses based on the data, 4. Testing hypotheses systematically, 5. Implementing solutions based on validated hypotheses, and 6. Verifying the resolution. For vSAN 6. 7. This framework must be augmented with specific knowledge of vSAN architecture, common performance bottlenecks, and the use of VMware's diagnostic tools. Question 11. Strategic planning requires a proactive approach to managing the lifecycle of critical infrastructure components. Given that VMware vSAN 6. 7 is nearing its end-of-support date, what is the most prudent strategic decision for an organization to ensure ongoing security, compliance, and operational stability? Option A. Initiate a phased migration plan to a currently supported version of VMware vSAN, ensuring ongoing vendor support and security patching. Option B. Immediately replace the entire vSAN infrastructure with an alternative storage solution to avoid any future VMware-related support issues. Option C. Extend the operational life of vSAN 6. 7 by seeking unofficial workarounds and community-based support for security issues. Option D. Continue operating on vSAN 6. 7. Implementing additional third-party security monitoring tools to mitigate potential risks. The correct answer is A. Initiate a phased migration plan to a currently supported version of VMware vSAN, ensuring ongoing vendor support and security patching. Explanation. Scenario analysis. This scenario presents a common challenge in IT infrastructure management where a critical component, VMware vSAN 6. 7, is approaching its end-of-support life. The challenge lies in balancing the immediate operational needs and budget constraints against the long-term security, compliance, and performance implications of running unsupported software. The organization must make a strategic decision that impacts not only the technical environment, but also its ability to meet regulatory obligations and maintain a secure posture. The pressure to defer upgrades due to cost is a significant factor, but ignoring the risks associated with unsupported software can lead to severe consequences, including data breaches, compliance violations, and operational disruptions. Correct approach analysis. The correct approach involves prioritizing a phased migration to a supported vSAN version. This aligns with best professional practices by proactively addressing the end-of-support lifecycle. From a regulatory and compliance standpoint, running unsupported software poses significant risks. Many regulatory frameworks, such as those governing data privacy and financial services, mandate that organizations maintain secure and up-to-date systems to protect sensitive data. Using end-of-support software can lead to non-compliance, resulting in fines, reputational damage, and loss of customer trust. A phased migration allows for controlled testing, minimizes disruption, and ensures that security patches and vendor support are available for the new environment, thereby upholding the organization's commitment to data integrity and security. Incorrect approach is analysis. Continuing to operate on the unsupported vSAN 6. 7 without a clear plan for remediation is a failure to adhere to responsible IT lifecycle management. This approach creates significant security vulnerabilities as no further patches or security updates will be released, leaving the system exposed to newly discovered threats. This directly contravenes the principle of maintaining a secure environment, which is often a regulatory requirement. Furthermore, relying on unsupported software can invalidate service-level agreements, SLAs, with vendors and support providers, and may also lead to non-compliance with industry-specific regulations that mandate the use of supported and patched software. Attempting to extend the life of vSAN 6. 7. Through unofficial workarounds or by relying solely on third-party security tools without addressing the core unsupported platform is also professionally unsound. While seemingly a cost-saving measure, it creates a false sense of security. These workarounds are not officially supported by VMware and may introduce instability or unforeseen compatibility issues. More importantly, they do not address the fundamental lack of vendor support and ongoing security patching, leaving the organization exposed to risks that could lead to regulatory penalties and operational failures. Seeking to immediately replace vSAN 6. 7 with a completely different non-VMware storage solution without proper evaluation and planning, solely to avoid the vSAN upgrade path, can be an equally flawed approach. While a strategic shift might be necessary long-term, a hasty, unplanned replacement can lead to significant integration challenges, increased costs due to unforeseen complexities, and potential disruption to critical business operations. This approach fails to leverage existing expertise and infrastructure effectively, and may not be the most cost-efficient or operationally sound decision without thorough due diligence. Professional reasoning. Professionals facing this decision should employ a risk-based approach. The first step is to thoroughly assess the risks associated with running unsupported software, including security vulnerabilities, compliance gaps, and potential operational impacts. This assessment should inform the development of a strategic plan that prioritizes remediation. The plan should outline a phased approach to migration, considering factors such as budget, resource availability, and business criticality. Regular communication with stakeholders, including IT leadership, security teams, and compliance officers, is crucial to ensure alignment and secure necessary approvals. The decision-making process should be documented, justifying the chosen path based on risk mitigation, compliance adherence, and long-term operational stability. Question 12. During the evaluation of a proposed upgrade to the vSAN 6, 7 clusters network configuration, which approach best ensures a comprehensive impact assessment? Option A. Relying on the vendor's release notes for the network hardware to confirm compatibility and assuming no adverse effects on vSAN functionality. Option B. Forming a limited set of connectivity tests between a few XC hosts and the vSAN data store after the network changes are applied. Option C. Implementing the network changes during a scheduled maintenance window and monitoring basic vSAN health checks for immediate anomalies. Option D. Conducting a thorough review of the vSAN 6. 7 design documentation, analyzing network traffic patterns, simulating failure scenarios, and documenting potential performance and availability impacts before implementing any changes. The correct answer is B. Performing a limited set of connectivity tests between a few XC hosts and the vSAN data store after the network changes are applied. Explanation. The scenario presents a common challenge in IT infrastructure management, assessing the impact of a proposed change on an existing, critical system like VMware vSAN 6. 7. The professional challenge lies in balancing the need for system improvement or new functionality against the inherent risks of disruption, data loss, or performance degradation. A thorough impact assessment is not merely a technical exercise. It's a crucial risk management process that directly influences business continuity and operational stability. Regulatory frameworks, while not explicitly detailed for this exam's jurisdiction, which is assumed to be a general IT best practice context without specific country-level regulations cited, emphasize due diligence, risk mitigation, and informed decision-making. The correct approach involves a systematic and comprehensive evaluation of all potential consequences of the proposed change. This includes understanding the interdependencies within the vSAN environment, identifying potential failure points, and quantifying the risk of adverse outcomes. Best professional practice dictates a proactive stance, where potential issues are identified and addressed before implementation. This aligns with principles of responsible system administration and IT governance, ensuring that changes are made in a controlled and predictable manner, minimizing the likelihood of negative impacts on data integrity and service availability. Incorrect approaches often stem from a lack of thoroughness or an underestimation of complexity. For instance, focusing solely on the immediate technical benefits without considering downstream effects or rollback strategies represents a failure in risk assessment. Similarly, assuming that a change will have no impact due to its perceived minor nature is a dangerous assumption that can lead to unforeseen and significant problems. Ethically, professionals have a duty to act in the best interest of their organization, which includes safeguarding data and ensuring system reliability. Any approach that bypasses due diligence or introduces unnecessary risk without proper mitigation can be seen as a dereliction of this duty. The professional decision-making process should involve a structured methodology. 1. Define the scope and objectives of the proposed change. 2. Identify all components and dependencies that the change might affect. 3. Analyze potential positive and negative impacts across technical, operational, and business domains. 4. Assess the likelihood and severity of identified risks. 5. Develop mitigation strategies for high-priority risks. 6. Plan for testing and validation. 7. Establish clear rollback procedures. 8. Obtain necessary approvals based on the assessment findings. Question 13. Cost-benefit analysis shows that upgrading to VMware vSAN 6.7 could offer significant performance improvements and potential cost reductions in storage infrastructure. However, a thorough impact assessment is crucial before proceeding. Which of the following approaches best represents a comprehensive and professionally responsible method for evaluating this upgrade? Option A. Focus the assessment primarily on the technical specifications of vSAN 6.7 and its compatibility with current hardware, with minimal consideration for operational changes or end-user impact, to expedite the upgrade process. Option B. Conduct a detailed impact assessment that includes evaluating potential disruptions to existing business workflows, the security implications of the new vSAN configuration, and its alignment with data protection and operational continuity requirements, alongside performance and cost metrics. Option C. Prioritize the upgrade based on the projected cost savings identified in the initial analysis, assuming that performance gains will naturally follow and that existing security protocols will remain sufficient. Option D. Implement the upgrade immediately to capitalize on the perceived cost benefits, deferring any detailed impact analysis until after the system is live and operational issues can be addressed reactively. The correct answer is C. Prioritize the upgrade based on the projected cost savings identified in the initial analysis, assuming that performance gains will naturally follow and that existing security protocols will remain sufficient. Explanation. The scenario presents a common challenge in IT infrastructure upgrades, balancing the perceived benefits of a new technology with the potential risks and costs, particularly when dealing with a critical system like vSAN. The professional challenge lies in conducting a thorough impact assessment that goes beyond superficial technical advantages to consider the broader implications for business operations, security, and compliance. This requires a nuanced understanding of vSAN 6.7's capabilities and limitations, as well as the organization's specific risk appetite and regulatory environment. The correct approach emphasizes a comprehensive evaluation of the impact of upgrading to vSAN 6.7. This involves not only assessing the technical performance gains, but also meticulously analyzing potential disruptions to existing workflows, the security posture of the new configuration, and its alignment with any relevant data protection or operational continuity regulations. A key aspect is the proactive identification and mitigation of risks, ensuring that the upgrade process itself and the post-upgrade environment meet established standards for availability and integrity. This aligns with best professional practices that prioritize risk management and due diligence in technology adoption. An incorrect approach that focuses solely on cost savings without a commensurate assessment of performance degradation or increased operational complexity fails to meet professional standards. Such an approach overlooks the potential for hidden costs associated with performance issues, such as decreased user productivity or increased support overhead. This can lead to a violation of implicit or explicit service level agreements and potentially impact business continuity, which could have regulatory implications if the organization is subject to uptime or availability mandates. Another incorrect approach that prioritizes rapid deployment over thorough testing and validation introduces significant risks. In a regulated environment, insufficient testing can lead to unforeseen security vulnerabilities or data integrity issues, which could result in non-compliance with data protection laws or industry-specific regulations. The failure to adequately assess the impact on security and compliance before deployment is a direct ethical and professional failing. A third incorrect approach that neglects to consider the impact on end-user experience and application compatibility overlooks a critical aspect of IT service delivery. While technical metrics might appear favorable, a degraded user experience or incompatible applications can lead to significant business disruption and reduced operational efficiency. This can indirectly lead to regulatory issues if the organization is obligated to maintain certain levels of service or productivity. The professional decision-making process for similar situations should involve a structured impact assessment framework. This framework should include stages for defining scope, identifying stakeholders, analyzing technical impacts, performance, scalability, compatibility, assessing operational impacts, workflow changes, training needs, evaluating security and compliance risks, and quantifying potential benefits and costs. A critical component is the development of a risk mitigation plan and a rollback strategy. This systematic approach ensures that all relevant factors are considered, leading to informed decisions that balance innovation with stability and compliance. Question 14. System analysis indicates that the VMware vSAN 6.7 environment is approaching its end-of-support date. What is the most appropriate next step to ensure the continued security, stability, and operational integrity of the storage infrastructure? Option A. Initiate a comprehensive impact assessment to evaluate the upgrade to a supported vSAN version, considering all technical, operational, and business implications. Option B. Continue operating with VMware vSAN 6.7 until a critical failure occurs, then address the issue reactively. Option C. Proceed with an immediate, unplanned upgrade to the latest vSAN version without prior assessment to minimize exposure time. Option D. Postpone any upgrade planning indefinitely, citing potential budget constraints and the perceived low immediate risk. The correct answer is A. Initiate a comprehensive impact assessment to evaluate the upgrade to a supported vSAN version, considering all technical, operational, and business implications. Explanation. Scenario analysis. This scenario presents a common challenge in IT infrastructure management where a critical component, VMware vSAN 6.7, is nearing its end-of-support life. The professional challenge lies in balancing the immediate operational stability and cost-effectiveness of continuing with the current version against the long-term risks associated with unsupported software, including security vulnerabilities and lack of vendor support. The need for a proactive approach is paramount, as a reactive response to a critical failure could have severe business implications. The decision-making process must consider technical feasibility, business impact, and adherence to best practices for maintaining a secure and supported environment. Correct approach analysis. The correct approach involves initiating a comprehensive impact assessment for upgrading VMware vSAN 6.7 to a supported version. This assessment is crucial because it systematically evaluates the potential consequences of the upgrade across all relevant areas. It ensures that all dependencies, potential disruptions, and resource requirements are identified and planned for. This aligns with professional best practices for IT lifecycle management, which mandate proactive planning for end-of-support scenarios. By conducting a thorough assessment, the organization can develop a robust migration strategy, minimize downtime, and ensure business continuity, thereby upholding its responsibility to maintain a secure and operational IT environment. This proactive stance is essential for mitigating risks and ensuring compliance with internal IT governance policies and industry standards for system maintenance. Incorrect approaches analysis. Continuing with VMware vSAN 6.7 without a clear upgrade plan is professionally unacceptable because it directly violates the principle of maintaining a secure and supported infrastructure. Once a product reaches its end of support, it no longer receives security patches or bug fixes from the vendor. This leaves the system vulnerable to known exploits, posing a significant security risk to the organization's data and operations. Furthermore, the absence of vendor support means that any critical issues encountered will be difficult or impossible to resolve, potentially leading to prolonged downtime and business disruption. This approach demonstrates a failure to adhere to responsible IT asset management and risk mitigation strategies. Deferring the upgrade indefinitely due to perceived cost or complexity is also professionally unsound. While cost and complexity are valid considerations, they should be addressed through detailed planning and resource allocation within the impact assessment, not used as a reason to avoid necessary maintenance. Ignoring the end-of-support status creates a ticking time bomb, where the eventual cost of a forced, emergency upgrade or a major security incident will likely far outweigh the costs of a planned migration. This approach neglects the long-term financial and operational health of the IT environment. Implementing an upgrade without a proper impact assessment is a high-risk strategy that can lead to unforeseen issues. Without understanding the dependencies, compatibility with other systems, and potential performance implications, the upgrade process itself could cause significant disruptions. This could result in data loss, application failures, or performance degradation, all of which are detrimental to business operations. This approach bypasses critical due diligence and demonstrates a lack of professional rigor in managing complex IT changes. Professional reasoning. Professionals should approach end-of-support scenarios by prioritizing a structured impact assessment. This involves 1. Identifying the end-of-support date and its implications. 2. Evaluating the current vSAN 6.7 environment, including its role, dependencies, and data criticality. 3. Researching supported vSAN versions and their upgrade paths. 4. Conducting a risk assessment of continuing with an unsupported version versus the risks of an upgrade. 5. Developing a detailed project plan for the upgrade, including resource requirements, timelines, testing, and rollback procedures. 6. Communicating the findings and recommendations to stakeholders, emphasizing the risks of inaction and the benefits of a planned upgrade. This systematic process ensures informed decision-making and minimizes the likelihood of negative consequences. Question 15. Regulatory review indicates that the introduction of a new vSAN 6.7 feature designed to enhance storage efficiency requires a thorough evaluation of its impact on existing data protection and disaster recovery strategies to ensure continued compliance with data resilience mandates. Which approach best addresses this requirement? Option A. Assume that existing data protection and disaster recovery mechanisms will automatically adapt to the new feature without requiring any specific validation. Option B. Conduct a comprehensive impact assessment that evaluates the feature's interaction with backup, replication, snapshotting, and disaster recovery processes, including potential performance implications on RPOs and RTOs. Option C. Focus the assessment exclusively on the storage efficiency gains of the new feature, as data protection and disaster recovery are separate operational concerns. Option D. Proceed with the feature's implementation, relying solely on vendor documentation to confirm compatibility with current data protection solutions. The correct answer is B. Conduct a comprehensive impact assessment that evaluates the feature's interaction with backup, replication, snapshotting, and disaster recovery processes, including potential performance implications on RPOs and RTOs. Explanation. Scenario analysis. This scenario presents a professional challenge due to the inherent complexity of assessing the impact of a new vSAN 6.7 feature on existing data protection and disaster recovery strategies. The challenge lies in anticipating potential unforeseen consequences and ensuring compliance with evolving regulatory expectations regarding data resilience and availability, even when the feature itself is not directly regulated. The need for a thorough impact assessment arises from the principle of due diligence, which requires proactive identification and mitigation of risks associated with technological changes. Correct approach analysis. The correct approach involves a comprehensive, multifaceted impact assessment that considers the feature's interaction with the entire data protection ecosystem. This includes evaluating its effect on backup windows, recovery point objectives, RPO, recovery time objectives, RTO, and the integrity of existing disaster recovery plans. It also necessitates understanding how the feature might alter the performance characteristics of the vSAN cluster, potentially impacting the effectiveness of replication or snapshotting mechanisms. This approach aligns with best practices in IT governance and risk management, emphasizing a holistic view of technology adoption and its implications for business continuity and regulatory compliance. By proactively identifying potential conflicts or performance degradations, organizations can ensure that their data protection strategies remain robust and meet all applicable regulatory requirements for data availability and recoverability. Incorrect approaches analysis. Focusing solely on the feature's intended functionality without considering its broader implications for data protection is a significant regulatory and ethical failure. This narrow perspective risks overlooking critical dependencies and potential vulnerabilities that could compromise data integrity or availability, leading to non-compliance with data protection regulations. Implementing the feature without any form of impact assessment, relying only on vendor documentation, represents a failure to exercise due diligence. This approach disregards the organization's specific environment and operational context, which are crucial for accurate risk evaluation. It can lead to unexpected disruptions, data loss, and ultimately, regulatory penalties for failing to maintain adequate data protection measures. Assuming that existing data protection mechanisms will automatically adapt to the new feature without verification is another critical failure. This assumption can lead to a false sense of security, masking underlying issues that could prevent successful data recovery during an incident, thereby violating regulatory mandates for data resilience. Professional reasoning. Professionals should adopt a proactive and comprehensive risk management framework when evaluating new technologies. This involves 1. Understanding the technology. Thoroughly grasp the intended functionality and potential side effects of the new vSAN 6.7 feature. 2. Environmental analysis. Assess how the feature integrates with the existing vSAN infrastructure, network, and storage components. 3. Data protection and DR assessment. Critically evaluate the feature's impact on RPOs, RTO, backup processes, and disaster recovery plans. 4. Performance and scalability testing. Conduct tests to ensure the feature does not negatively affect cluster performance or the ability to meet recovery objectives. 5. Documentation and validation. Document all findings, potential risks, and mitigation strategies, and validate the effectiveness of the data protection and DR plans post-implementation. 6. Regulatory alignment. Continuously ensure that all implemented solutions and processes align with relevant data protection and business continuity regulations. Question 16. The performance metrics show a consistent increase in latency and a decrease in throughput for a critical VMware vSAN 6.7 cluster supporting a financial trading application. Which of the following actions best represents a responsible and effective initial response to this situation? Option A. Temporarily disable non-essential services running on the vSAN cluster to free up resources and observe if performance metrics improve. Option B. Immediately increase the size of the vSAN cache tier and reconfigure network interface card (NIC) settings on all hosts to potentially alleviate the performance bottleneck. Option C. Initiate a comprehensive impact assessment to identify the root cause of the performance degradation, evaluate potential solutions, and understand their implications on the financial trading application's stability and compliance requirements before implementing any changes. Option D. Roll back the vSAN cluster to a previous known good configuration without further investigation into the current performance metrics. The correct answer is C. Initiate a comprehensive impact assessment to identify the root cause of the performance degradation, evaluate potential solutions, and understand their implications on the financial trading application's stability and compliance requirements before implementing any changes. Explanation. The performance metrics show a consistent increase in latency and a decrease in throughput for a critical VMware vSAN 6.7 cluster supporting a financial trading application. This scenario is professionally challenging because the direct impact on a financial trading application can lead to significant financial losses, reputational damage, and potential regulatory scrutiny. The urgency to resolve performance issues without introducing further instability or downtime is paramount. The correct approach involves a systematic, data-driven impact assessment that prioritizes understanding the root cause of the performance degradation before implementing any changes. This aligns with best professional practices for IT operations and system administration, emphasizing proactive problem-solving and minimizing risk. Specifically, for a financial application, adherence to service-level agreements, SLAs, and regulatory compliance, e.g., related to data integrity and availability, is critical. A thorough impact assessment ensures that any proposed remediation steps are evaluated against their potential to disrupt services, violate compliance requirements, or negatively affect business operations. This methodical approach, which includes analyzing the scope of the problem, identifying potential causes, and evaluating the risks associated with different solutions is essential for maintaining system stability and meeting business objectives. An incorrect approach would be to immediately implement a broad, unverified fix without a proper impact assessment. For instance, blindly increasing cache sizes or reconfiguring network settings without understanding the underlying cause could exacerbate the problem, lead to data corruption, or violate security policies. This haste bypasses the necessary due diligence required to ensure system integrity and compliance. Another incorrect approach is to ignore the performance degradation, hoping it resolves itself. This is professionally unacceptable as it demonstrates a lack of diligence and can lead to severe consequences, including breaches of SLAs and potential regulatory violations related to system availability and reliability. Furthermore, making changes based on anecdotal evidence or assumptions rather than concrete data and a structured assessment is a direct failure in professional judgment and risk management. Professionals should employ a structured decision-making framework that begins with clear problem identification, followed by data collection and analysis. This leads to hypothesis generation about the root cause, followed by the evaluation of potential solutions, including their impact on performance, stability, and compliance. Risk assessment for each proposed solution is crucial, and the chosen solution should be implemented with a rollback plan and thorough monitoring. This systematic process ensures that decisions are informed, risks are managed, and the best possible outcome is achieved while adhering to professional standards and regulatory expectations. Question 17. The efficiency study reveals that a legacy application is consuming a disproportionate amount of vSAN cluster resources, leading to performance degradation for other critical workloads. Which of the following strategies best addresses this situation while minimizing risk to the overall vSAN environment? Option A. Increase the overall capacity of the vSAN cluster by adding more hosts and disks without analyzing the specific resource contention. Option B. Implement a dedicated vSAN data store for the legacy application, with storage policies specifically tuned to its I/O characteristics, and conduct a phased migration. Option C. Immediately reconfigure the existing vSAN data store storage policies to prioritize the legacy application's I/O, assuming it will resolve the issue. Option D. Ignore the efficiency study's findings and continue with the current configuration, as the legacy application is deemed essential. The correct answer is B. Implement a dedicated vSAN data store for the legacy application, with storage policies specifically tuned to its I/O characteristics, and conduct a phased migration. Explanation. The efficiency study reveals that a significant portion of the vSAN cluster's performance is being consumed by a legacy application that is not optimized for modern storage architectures. This scenario is professionally challenging because it requires a deep understanding of vSAN internal workings, the application's resource demands, and the potential impact of changes on business-critical operations. The decision-maker must balance performance improvements with the risk of service disruption, and ensure compliance with any relevant VMware licensing or support agreements. Although this specific exam focuses on technical implementation rather than licensing, the correct approach involves a phased, controlled migration of the legacy application to a dedicated vSAN data store, configured with performance steering and appropriate storage policies tailored to its specific I/O patterns. This represents best professional practice because it minimizes risk by isolating the application, allows for granular tuning of vSAN resources, and provides a clear rollback path if issues arise. It aligns with the principle of least privilege and controlled change management, ensuring that the impact on other vSAN workloads is negligible. An incorrect approach would be to immediately reconfigure the existing vSAN data store to accommodate the legacy application's demands without proper isolation or testing. This is professionally unacceptable because it introduces a high risk of performance degradation for all other workloads on the vSAN cluster, potentially violating service-level agreements and causing widespread business disruption. It demonstrates a failure to conduct a thorough impact assessment and a disregard for the interconnected nature of shared storage resources. Another incorrect approach would be to attempt to fix the legacy application's performance issues by simply increasing the number of vSAN hosts or disks without understanding the root cause. This is a costly and inefficient solution that fails to address the underlying problem and can lead to over-provisioning and wasted resources. It represents a lack of analytical rigor and a failure to apply a systematic problem-solving methodology. A further incorrect approach would be to ignore the efficiency study's findings and continue operating with the suboptimal performance. This is professionally negligent, as it allows a known issue to persist, impacting productivity and potentially leading to increased operational costs due to inefficient resource utilization. It demonstrates a lack of proactive management and a failure to leverage available data for system improvement. The professional decision-making process for similar situations should involve 1. Thoroughly understanding the findings of any performance or efficiency studies. 2. Identifying the root cause of the identified issues, considering both application and infrastructure factors. 3. Developing a phased remediation plan with clear objectives, rollback procedures, and testing protocols. 4. Communicating the plan and potential impacts to all relevant stakeholders. 5. Executing the plan in a controlled manner, monitoring closely for any deviations. 6. Documenting all changes and outcomes for future reference and continuous improvement. Question 18. Implementation of a storage capacity expansion for a VMware vSAN 6.7 cluster hosting critical business applications requires careful consideration to maintain data availability and performance. The current cluster is operating at 85% capacity, and immediate expansion is requested. What is the most professional and risk-averse approach to address this requirement? Option A. Increase the number of disk groups on existing hosts without adding new hosts. Option B. Migrate existing virtual machines to external storage arrays to free up space on the vSAN data store. Option C. Immediately add new storage devices to existing hosts to increase available capacity. Option D. Plan and execute a phased expansion by adding new hosts with appropriate storage devices, ensuring the cluster health and network bandwidth are assessed before and after integration. The correct answer is C. Immediately add new storage devices to existing hosts to increase available capacity. Explanation. This scenario presents a common challenge in virtualized storage environments, ensuring data integrity and availability while adhering to performance and operational requirements. The professional challenge lies in balancing the immediate need for storage expansion with the long-term implications of data placement, network traffic, and potential performance bottlenecks, all within the context of vSAN 6.7's architectural principles. Careful judgment is required to avoid introducing instability or compromising the service level agreements, SLAs, for critical applications. The correct approach represents best professional practice because it prioritizes a phased and controlled expansion that minimizes disruption and risk. By first assessing the existing cluster's health, understanding the specific workload requirements, and then strategically adding hosts with appropriate hardware, the administrator ensures that the new resources are integrated seamlessly. This proactive approach aligns with the principles of robust infrastructure design and operational excellence, which are implicitly expected in professional IT roles. It avoids introducing unknown variables into a production environment and allows for validation at each step. An incorrect approach that involves immediately adding disks to existing hosts without considering the cluster's overall balance or the impact on network traffic is professionally unacceptable. This could lead to uneven disk distribution, increased network congestion as vSAN rebalances data, and potential performance degradation for existing workloads. Such an action demonstrates a lack of foresight and a failure to adhere to best practices for managing distributed storage systems, potentially violating implicit service level agreements and impacting business operations. Another incorrect approach, such as migrating existing VMs to new storage before the new hosts are fully integrated and validated, introduces significant risk. This bypasses the controlled expansion process and could result in data loss or corruption if issues arise during the migration, or if the new storage is not properly configured. This is a direct violation of professional responsibility to maintain data integrity and system stability. The professional reasoning process for similar situations should involve a systematic evaluation of the current state, a clear understanding of the desired outcome, and a phased implementation plan. This includes 1. Assessing the existing infrastructure's capacity and health. 2. Defining the specific requirements for the expansion, e.g., capacity, performance, redundancy. 3. Planning the integration of new resources, considering hardware compatibility and network topology. 4. Executing the expansion in controlled stages, with validation at each step, and 5. Monitoring performance and stability post-expansion. This structured approach mitigates risk and ensures a successful outcome. Question 19. Quality control measures reveal intermittent performance degradation across several virtual machines hosted on a VMware vSAN 6.7 cluster. Users report occasional slowdowns and unresponsiveness, but these issues are not constant and seem to occur at random intervals. The vSAN health check reports no critical errors, and all components are showing as green. However, detailed performance metrics from vCenter show spikes in disk latency and reduced IOPS on specific XC hosts within the cluster during these reported slowdowns. Which of the following is the most appropriate initial course of action to diagnose and resolve these intermittent performance issues? Option A. Randomly update firmware and drivers on all XC hosts and storage controllers across the cluster in an attempt to address any potential compatibility issues. Option B. Systematically collect and analyze vSAN health logs, XC host logs, disk performance metrics, and vCenter performance data to identify patterns and potential root causes. Option C. Advise users to simply restart their virtual machines whenever performance issues are encountered, as this often resolves temporary glitches. Option D. Immediately initiate a full vSAN cluster rebuild and reformat all underlying storage devices to ensure a clean slate. The correct answer is B. Systematically collect and analyze vSAN health logs, XC host logs, disk performance metrics, and vCenter performance data to identify patterns and potential root causes. Explanation. Scenario analysis. This scenario presents a professional challenge due to the potential for data corruption and performance degradation in a critical vSAN environment. The challenge lies in identifying the root cause of the intermittent performance issues and determining the most effective and least disruptive remediation strategy. The need for a swift resolution is paramount to minimize impact on business operations, while simultaneously ensuring data integrity and compliance with any relevant VMware support policies or best practices. Correct approach analysis. The correct approach involves a systematic and data-driven investigation. This begins with gathering comprehensive logs and performance metrics from the vSAN cluster, including host logs, vSAN object health status, and disk performance data. Analyzing these logs for specific error patterns, disk I/O anomalies, or network latency issues is crucial. Based on this analysis, a targeted troubleshooting plan can be developed, which might include firmware updates for storage controllers, driver updates, or even the replacement of a suspect disk or host. This methodical approach aligns with best professional practices by prioritizing data integrity, minimizing downtime through informed decision-making, and adhering to established troubleshooting methodologies for complex storage systems. It ensures that any remediation steps are based on evidence rather than speculation, thereby reducing the risk of introducing new problems. Incorrect approach is analysis. One incorrect approach would be to immediately initiate a full cluster rebuild or reformat all disks without a clear diagnosis. This is a highly disruptive and potentially data-destructive action that is not justified by intermittent performance issues. It represents a failure to follow a structured troubleshooting process and could lead to significant downtime and data loss, violating professional responsibility to protect client data and maintain service availability. Another incorrect approach would be to ignore the intermittent performance issues, assuming they will resolve themselves or are within acceptable tolerance. This demonstrates a lack of diligence and a failure to proactively address potential problems. Such inaction could lead to a more severe failure down the line, impacting business operations and potentially violating service-level agreements or support obligations. It also fails to uphold the professional standard of ensuring the stability and reliability of the deployed infrastructure. A third incorrect approach would be to randomly apply configuration changes or updates across the cluster without understanding their potential impact or relevance to the observed symptoms. This shotgun approach is inefficient and increases the risk of unintended consequences, such as introducing new performance bottlenecks or destabilizing the cluster. It signifies a lack of analytical rigor and a departure from evidence-based problem-solving, which are fundamental to professional IT operations. Professional reasoning. Professionals should approach such situations by first establishing a clear understanding of the reported symptoms and their business impact. This is followed by a systematic data collection phase, leveraging available tools and logs to gather evidence. The analysis of this evidence should guide the development of a troubleshooting plan, prioritizing non-disruptive actions where possible. Remediation steps should be carefully planned, tested in a non-production environment if feasible, and executed with clear rollback procedures. Continuous monitoring after remediation is essential to confirm the resolution and prevent recurrence. This structured, data-driven, and risk-aware decision-making process ensures that the most effective and responsible solutions are implemented. Question 20. Stakeholder feedback indicates a sudden and significant performance degradation across multiple virtual machines hosted on a VMware vSAN 6.7 cluster. Initial observations suggest that the issue began shortly after a recent network configuration adjustment was made to the underlying physical infrastructure supporting the vSAN network. The IT operations team is under pressure to restore optimal performance immediately. Which of the following approaches best addresses this situation while adhering to professional best practices for managing a vSAN environment? Option A. Initiate a full vSAN cluster reboot to clear any potential transient issues and restore performance. Option B. Apply a series of random performance tuning parameters to the vSAN cluster configuration in an attempt to identify a fix. Option C. Immediately revert the recent network configuration changes on the physical infrastructure to their previous state, and then monitor vSAN performance. Option D. Conduct a thorough review of vSAN health checks. Examine vSAN performance metrics for disk groups and network adapters, and correlate these findings with the timing of the network configuration changes to identify the specific bottleneck. Correct answer is C. Immediately revert the recent network configuration changes on the physical infrastructure to their previous state, and then monitor vSAN performance. Explanation. Scenario analysis. This scenario presents a challenge in balancing performance optimization with data integrity and availability requirements within a VMware vSAN 6.7 environment. Stakeholders are concerned about potential data loss or performance degradation due to an unverified configuration change. The professional must navigate the technical complexities of vSAN while adhering to best practices and ensuring compliance with internal policies and potentially external regulations regarding data handling and system stability. The challenge lies in identifying the root cause of the performance issue without introducing further risk. Correct approach analysis. The correct approach involves a systematic, non-disruptive investigation. This includes reviewing vSAN health checks, examining performance metrics for specific components, disks, network, VM, and correlating these with recent configuration changes. The focus on identifying the specific vSAN object or component experiencing the performance bottleneck, and then analyzing its configuration and health status, is paramount. This methodical approach minimizes the risk of further disruption, ensures data integrity by avoiding hasty changes, and aligns with professional IT service management principles that prioritize stability and controlled remediation. The absence of specific regulatory frameworks for this exam means adherence to general IT best practices and vendor guidelines. VMware is the implicit standard. Incorrect approaches analysis. Implementing a broad, unverified configuration change across the vSAN cluster without proper analysis is a significant professional failure. This approach bypasses essential diagnostic steps, increasing the risk of exacerbating the performance issue or causing data corruption. It demonstrates a lack of due diligence and a disregard for the potential impact on data availability and integrity. This is ethically unsound as it prioritizes a quick, albeit risky, fix over a stable and reliable system. Rolling back all recent configuration changes without pinpointing the specific cause is also problematic. While it might resolve the issue, it doesn't address the underlying problem and could lead to the same issue recurring. It also represents a failure to learn from the incident and improve system resilience. Professionally, this is a reactive measure that doesn't foster a proactive and analytical approach to system management. Ignoring the stakeholder feedback and continuing with the current configuration, hoping the issue resolves itself, is a clear dereliction of professional duty. This approach demonstrates a lack of responsiveness to user concerns, and a failure to proactively manage system performance can lead to prolonged downtime or degraded performance, impacting business operations and eroding trust. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This involves understanding the reported issue, gathering relevant data, logs, metrics, configuration, forming hypotheses, testing those hypotheses in a controlled manner, and implementing solutions based on evidence. When dealing with critical infrastructure like vSAN, a phased approach with rollback plans is essential. Prioritizing non-disruptive troubleshooting, thorough documentation, and clear communication with stakeholders are key to maintaining system integrity and professional credibility.